Hello and welcome to this KHL webinar, Realising Connected Construction, which we are bringing to you in association with Trimble. My name is Andy Brown and I'm the editor of International Construction magazine. We've had a good response to this webinar so far. So I was told just before we started this, we've had close to 300 registrations from people all over the world. So I'd like to thank you all very much for joining us. I hope that wherever you are well. I know it's still difficult times for many people, but hopefully we'll all be able to see each other in person at some point soon. This webinar will last for approximately 45 minutes, perhaps a touch longer, and we'll be talking about the connected construction site with two experts. I would just like to highlight now that you can ask questions to our speakers, and in fact we would encourage you to do so, and you can do this by using the Q&A function, which you should see at the bottom of your screen. So I will be keeping my eye out on that, so please do send over any questions and I will get them to the panelists. So talking about our panelists, I would like to welcome them now. So we have Cameron Clark, Earthmoving Industry Director at Trimble. Hello, Cameron. Thanks for joining us. How are you?
Yeah, good, thanks. Yeah, welcome to be here. I'm looking forward to it.
Great. Thanks, Cam. And we also have Sam Williams, who's an engineering surveyor for MJ Church. They're a contractor based in the UK, and they've set out to transform civil workflows with technologies to connect the office with the work in the field. Sam, thank you for your time. Are you well?
I'm well, thank you, Andy. Thank you very much for having us here. Really keen to share our knowledge.
Great. Well, thank you. We're very lucky to have two very good speakers, and we do have a presentation which we will run through. But before we run through that presentation, I've just got a couple of quick questions for Cameron and for Sam. So first of all, my first question is for Cam. So we're going to be talking about different technologies today, but one of the main ones we're going to be talking about is machine control. So before we begin, and obviously there'll be people watching this webinar at kind of different kind of technical knowledge levels, but before we begin, could you give us a quick definition of machine control and perhaps how it's evolved over the last few years?
Yeah, sure. Yeah, no, it's quite important to do so because a lot of people don't necessarily, they're not exposed to machine control and they don't know what it is. So really at the simplest form, machine control uses various sensing and positioning sensors, etc., and a display to provide the operator in the machine with a reference from where, say, the bucket or the blade is to a target grade. And that target grade could be a 3D model or a design, or it could be as simple as a distance from the bucket or blade to a known bench point or hub, or it could be a distance offset from a laser. And really, depending on your configuration or machine system, the machine control systems can provide just visual guidance to an operator, or they can actually automatically control the implement to that target grade. And typically, you'd mount sensors in locations that move on the machine that you need to know in order to calculate where the bucket is, or the blade, or the implement. So for an excavator, for example, you'd have a sensor on the boom and the stick and the bucket. And as you move the boom, we can dynamically calculate where the bucket is. Or on the blade of a dozer, you could put masts or GPS receivers directly to the blade. And then as the blade moves, you've got a direct measurement of it. But as technology has evolved with more horsepower in the computers, better sensors, you've actually got the ability now to remove those masts and receivers off the blade and actually have them on the cab. And that's great for operators because now you don't have to worry about hitting the masts or damaging the receivers. And there's other things that have evolved over time with more satellites that have been launched, different satellite systems, and this provides greater uptime, greater availability, which drives to better accuracy and precision. And there's other ways as well where you can augment the 3D GPS position with lasers to get millimeter accuracy, as well as 3D is offered using total stations to actually provide positions where you can't see the sky or you've got limited visibility. But really, just about any sort of machine you can get a system for. Very quick overview, but I'd suggest that if you want to know more, contact your local SciTech dealer, which is Trimble's technology distribution network. And it's very easy to find who your local SciTech dealer is. You just go into trimble.com, hit the dealer locator button, select your country and make sure you've selected construction, and then you'll be given all the details to see who your local dealer is and go from there.
Okay, great. Thanks, Cam. And just quickly, we've had a couple of questions that have already asked about whether the recording will be available to watch later. So the answer is yes, the recording will be on khl.com, and we can also put these slides on there as well. I've got a question then for you, Sam. There's obviously going to be people watching this at different levels of their construction tech journey. Could you give us a quick kind of overview of how you became interested in construction tech, and maybe how central it is now to everything that you do?
Yeah, sure, Andy. So I still feel like I'm fairly early into my construction journey, but I think I've gained quite a lot of experience in that time. So I started as a site engineer with a tier 1 contractor in the UK, where I was setting out earthworks and flood defence structures, reinforced concrete, and general surveying. But I largely had a passion for machine control and construction technology. So I'd always look for opportunities throughout my career to enhance sort of the techie side of construction, and to try and expose myself to as many different technology providers and as many different solutions to construction technology that I could expose myself to. So with that in mind, I made the move just over a year and a half ago now to MJ Church to pursue machine control and to be able to part own the machine control fleet and the development and the deployment of that fleet from a sort of a holistic point of view. I always felt a little bit frustrated in the tier 1 enclosure that I couldn't, it was always slightly fragmented machine control. Whereas now I work for a subcontractor where we have machine control at its core. We can own every facet of machine control from the start to the finish, and we can deploy it with our full understanding of the equipment and our full experience of the equipment, and deliver real efficiency gains for our clients.
Okay, great. Thanks, Sam. I think being quite modest there as well in terms of where you are on the journey. So Cam, just a quick question for you then. What kind of adoption rates is the construction industry seeing when it comes to machine control?
Yeah, that is a good question, and it really changes by region. For example, the Nordic countries in Europe, they're heavily adopted and they're the leading users of, say, excavators and grade control. Factors like entry-level factory systems have also helped adoption by getting a further reach and exposure to some contractors through the OEM channels. And as well as programs, say, like Trimble Ready, which make it very easy for SciTechs to, in the aftermarket, add on technology to machines. Growth of systems sold on excavators has been very strong. And with machine control solutions, you can make a machine that's already very versatile, even more versatile, and actually do tasks that you may have used another machine for. For example, with the automatics on an excavator, you no longer need, say, a dozer to finish behind you if you're doing a side slope. You're getting what you need straight away. And when you look at the number of machines sold and the applications that they're used in, excavators are the most opportunity-rich machine control. And they are growing faster, the sales, than dozers and graders. However, adoption rates are still lower due to the number of machines sold every year. But really, it's hard to put a finger on the exact adoption rate. It really changes by region. But one thing I can comment on is that excavators is the most opportunity rich. They're growing, but due to the fact of so many excavators sold, the adoption rates are still a lot lower than the other machines.
Okay, thanks, Cam. And I've got a question for you, Sam. And actually, the question that I was planning to ask you is quite similar to one of the ones that's come in from the Q&A I can see. So I'll ask the one from the Q&A. So that's from Julian Hayes. So thank you for your question. And Julian asks, do the panelists think that in the future project developers are going to require contractors to have machine control and similar tech, or is this already the case? So if you could maybe, Sam, if you could just sort of give us your experience of that, whether this is something that people are already asking for or expect.
Absolutely. I think in my short career so far, in the last 5 years, I've seen it change massively already. That the adoption of machine control on sites is growing what feels exponentially. It's hard to drive around in the UK now on motorways and you see the odd site off to the right, will let you know. They've got pods on them now, and we're moving to a point where machine control is being deployed on sites and people are really beginning to see the advantage of it. And I've seen within the bid framework, within when we tender for work, as a department, we've spent quite a lot of time over the last year and a half building our confidence in machine control and demonstrating to our bid writers and to our directors that we have the competency and the capability to deliver machine control on our sites. And we've built that confidence with our bid submissions, and we are, as a business, advertising ourselves in full force to our potential clients and saying, look, we have this capability, we have the experience, we have the right people in the right place, the right equipment, and it is helping us to win work, absolutely. And there are some large contractors and some large clients like Highways England that are beginning to write these requirements into their schemes now. It's what's refreshing for me is it's no longer becoming a question of, are you going to use machine control? It's becoming a question of, why aren't you going to use machine control? It becomes difficult to justify why you're not going to use machine control. And I think that's where we have a real competitive edge.
Okay, that's really interesting. Thank you. Okay, so I'll hand over to you now, Cam, quickly, if you'd like to. I know you've got some slides to go through.
Yeah, sure. So yeah, welcome again, everybody. I wanted to start this session off by really acknowledging some of the key fundamental changes in construction that we've seen over the last 20 plus years. We've seen a great continuous improvement process from stakes and string lines for having to eyeball between the stakes. Then lasers came along and you didn't need to eyeball anymore. We've gone from indicate guidance to automatics and being able to do automatics off lasers and being able to trace automatics off a string line or say an existing pass. So then we've gone to 3D where you don't need stakes anymore. You don't have to worry about machines running them over. And you can actually get guidance wherever you are. You've got all the information in the machine and we can control the machine to complex surfaces. But we've also seen the connection between the office and the field. And we've gone from really hard to set up radio networks and like really hard to set up, I mean crazy hard, just to do simple things like file transfer. I remember back in the day, like years ago, 15 plus years doing FTP file transfer of a command line, just testing and just the pains it was to set things up. But now we've got a lot better connectivity. We've gone from no cell phone coverage to very patchy to things are now easier, they're quicker, there's more reliable solutions. Some areas are still bad, but when you look at how far it's come, it's dramatically changed over the decades. This has really enabled the construction industry to leverage site connectivity for the flow of information and to strive to improve efficiency and productivity while minimizing waste, cost at every stage of the project. And as the industry has been changing, contractors are now looking at technology to aid them, to differentiate themselves, and in some cases, having to actually adopt just to stay in the game. So yeah, we've come a long way.
Okay, that's quite interesting, Cam, because I think sometimes a lot of people talk about the construction industry being quite a slow kind of industry to kind of adopt new tech, and obviously there's more that needs to be done. And you said that there's some areas that it's still not great, but maybe we're a bit hard on ourselves sometimes. Then, if you think of where we've come from in 20 years or something.
Yeah, no. When you look at it, and I've got another slide that I'll touch on it as well. But yeah, the construction has been slow to adopt technology compared to other industries, and really has only seen about a 1% growth in annual productivity in the last 30 years. And nearly 50% of construction companies have reported spending 1% less on technology annually. And that's a lot less compared to other areas. But things are changing, and contractors more and more understand the value. For a long time, and I guess partially still true today, but nowhere near as much, you used to hear the things about, I don't need to embrace, I've always done it like this, we don't work that way, sort of thing, or it doesn't apply to us, or it's only for the big guys. So there was definitely a mindset there, with the barrier, but also I think some of it, there was that people thinking it was actually too hard to learn, and if it went wrong, what can I do? I'm stuck, sort of thing.
Mhm.
But a lot of things have changed, and there's a younger generation coming through as well that have grown up with technology, and they embrace it. And a lot of these people as well as are in influential positions, and they're reducing these barriers. And I believe that we're going to see far greater adoption of technology at a rapid pace, because technology does and will solve issues with lack of skilled labor, as well as the need of safety and sustainability, while meeting the productivity demands that the industry needs. Okay, well, I'll jump to the next slide if that's good, Andy. So touching on, I guess, your question as well, even with the major developments and what I showed earlier, the construction industry isn't achieving the possible gains. And with that, costs are up nearly 5%. That was reported in 2009, say, in the US. And they're steadily increasing due to labor shortages, as well as the increasing price of materials. And we've really, in the construction industry, failed to see some of these technologies being adopted like in other industries. Primarily driven by just really some of those mindset changes that I've talked about as well. And when you look at it, about 30% of work is performed on construction as rework. And these can be caused like factors like lack of supervision, insufficient information, limited resources, failed communication, and I think one that we're going to touch on a lot today is disjointed activities where the same data or models are not used throughout the job, and these drive an immense cost. And as well as even in the US alone, with the 2008 financial crisis, there was about 1.5 million jobs that were lost in construction, and a lot of these never returned. When you compound that with an aging workforce that's retiring, as well as a lack of an holistic apprenticeship program, there's a brain drain that's really hard to recover from. So it's not only a supply and demand issue, but it's also forcing increased labor wages that risk the project profitability. But today, it's not all doom and gloom, and we want to really highlight how things can change and come together when we connect these workflows. And you as a contractor can really realize these in connected construction. So when you look back at rework, it's not surprising that if people aren't using the same data and you don't have the flow of information, that there's about 30% of rework happening. And having connected construction can really help reduce this. So disjointed activities, they occur when the data isn't flowing back and forth through the course of the project. And you've got different activities or tasks that aren't using the same informational model as well. And when you look at the typical flow from plan, design, build, and operate, as you progress through it, the cost of change increases rapidly, and then also your ability to change decreases, as illustrated in the graphic. And when you think about it, how often have you heard of contractors coming into a job and finding something's wrong? And a lot of times they're finding it once they actually start cutting dirt or moving material. Maybe the elevation's wrong or the utilities are in the way. Sometimes you can actually start and do a workaround. Other times you're stuck and you've got to wait for a design change. So, but if you can visualize data and all aspects of the project beforehand and using the same models and data, you've got the ability to change very high and quickly and easily with as minimal cost as you can. So when you look at Trimble and how we've evolved, we've gone from point solutions and focusing on areas of GPS, then other positioning sources, to dramatically improve productivity. But then the key area of focus now is integrated work processes. And it's an ecosystem solution for the whole value chain or life cycle. And our mission is to really transform the way the world works. And our vision is to connect the digital and the physical worlds. And really in order to allow the customers to deliver with confidence. So to do this, you need to connect all the processes and task management through all the different personas on the construction site and through the whole chain, as well as both the vertical and horizontal civil construction processes. And this really drives quality, productivity, transparency, safety, and sustainability. And Trimble is unique where we offer solutions that integrate throughout the whole life cycle of the construction life cycle. Coupled that with the support of our construction technology distributor network of SciTech, well, we've got your needs covered. And really today we wanted to highlight with Sam from MJ Church, and he's going to go into specifics about the value that they see with connected construction and how they realize this value. And Sam will be touching on real life examples for the model creation, design, management, and office to field workflows, remote monitoring, support, and training, and then also the real-time capture of field data and the benefits of that data coming back to the office automatically. And then also for not having to send surveyors out to do as-built, being able to do stuff like that with the machines directly and from information that they can capture.
Okay, great. Thanks, Cam. There's another good question here that I'd like to ask, which I think I'll direct to you first, Cam, but you might have a view on it as well, Sam. So it's from, and you must forgive the pronunciation of your name, I'm going to absolutely murder it, I'm sure, but from Anton Chazelle, who asks, who finally implements machine control? The equipment OEM question mark, the contractor question mark, a company support construction site like Trimble question mark?
So can you just repeat the question, the start of it?
Yeah, sorry. So they're basically asking who it is that finally implements the machine control. Is it the equipment OEM? Is it the contractor? Is it a company like Trimble?
I guess it's a mix, really. When you think about where we've come from, it's technology companies, say as Trimble and our competitors, that are really providing solutions to really show productivity and see the gains and being able to fit out on any machine. And with that, OEMs, they can spend millions of dollars and years of investment to work on undercarriages and all sorts of things on machines to get very little % productivity gains compared to, say, a technology of machine control that you put on a machine where you can instantly see like 30% productivity for a lesser skilled operator. So with that, OEMs they understand it, they're making the machines more applicable and designing things to support machine control and offering things out of the factory. So really, it's not just one or the other, it's sort of an evolution that's changed. And then you also see a lot of times where some contractors are very, very skilled and they've got a lot of IT capability and they're making their own solutions. But that's not really scalable for global use sort of thing. So you need companies like Trimble and others to really tailor it and work with companies to provide a solution with the support as well that your customers need if something goes wrong. So I'd answer it in that way where it's not just one or the other, it's sort of all facets in a way.
Okay, great. Thanks, Cam. Okay, do you want to go into the next slide?
Yep. Can do.
So this is where I jump in and give a real world experience of what I think is fair to say, sort of realizing Trimble's vision. I think one of our goals as a team from the beginning was to, as much as practical, realize the vision of a connected site and all the technologies that encompasses. and to see what we can do with it, really. Being interested in technology is always fascinating to see how we can use things in a different way, or try and use our existing equipment in a more optimized workflow. So I've tried to frame this presentation around one of our example projects. It's acting as sort of a proving ground of all of this machine control technology and this fully connected real life site. It's been our proving ground, and the lessons we've learned there and the knowledge that we've gained there, we're now a year and a half on, we're now trickling down into all of our other sites across the country, really. And the technology that we've developed here will be moving forward into all of our future projects as best we can. We're investing heavily still in machine control and the technology that comes along with it. So the Dorset Visual Impact Provision is a project in the southwest of England, in the United Kingdom. So MJ Church are working on behalf of Morgan Sindall and National Grid. So the site down there is designated as an area of outstanding natural beauty. And the scheme that we're undertaking is to facilitate the removal of these 400,000 volt overhead transmissions lines to improve the visual appeal of the area. Where are they going? They've obviously got to go somewhere because they've been taken down. So we are putting in about 8.5 kilometers worth of 400,000 volt cable trenches. So we've got big ducts in the ground, and the cables, we run through cables through there, and that diverts the energy underground. It's an incredibly challenging site for us in terms of the terrain, the topography, and just the design constraints that have been imposed upon us as contractors that we have to work to. And it was quite clear from us from the beginning that machine control would play an invaluable role in helping us to achieve the project objectives. So we've used GPS rovers, total stations. We were involved heavily in the initial topographical survey of the site to figure out the levels. And then we've been involved heavily in the design, well, realizing the design and digging it on site. So if we could just jump to the next slide, please, Cal. So 3D model creation, this is what saps quite a bit of my time, but it's one of the areas that I'm particularly interested in and have become fairly skilled in over the years. So we use Trimble Business Center, which, if you do nothing else after this webinar, go away and just look at how you might want to use it or get a trial of it, because it is, for me, the one-stop shop of modeling softwares. There's not much it can't do. And it is really, it does some amazing stuff, and they're constantly improving it. Instead of having a fragmented approach, which you might find with other providers, pretty much everything is bolted into the one suite. There's little add-ons here and there, depending on your workflow. But it is an amazing tool. So the designer on this particular project has provided us with fairly limited 2D detail, which isn't particularly useful when you've got a machine control fleet that needs a 3D model to dig to. So they provided us this information in a variety of different formats, PDFs, 2D DXFs, all sorts of other industry formats. TBC can import all of that data, we can manipulate it, we can elevate 2D data to 3D, and do all sorts of modeling on it, and then push that to the field for construction. So on this particular project, we've been using Trimble Business Center to create corridor models effectively. So we have these, we need to dig the trenches to quite a tight grade. We have a very small, a very narrow window that we need to thread these trenches through to meet the specification. That specification is particularly tight because 400,000 volts underground is a lot of energy. Heat dissipation is a major issue. If we go too deep and the trench isn't wide enough to account for the difference in depth, you could end up with a situation where a cable could explode because of the heat can't dissipate quick enough. So proving to our client that we've excavated these trenches to the correct depth and specification is critical for us. And the machine control, the full machine control across this site gives us absolute confidence beyond reasonable doubt that we've met the specification. So as I said before, we've been provided with 2D data for these trenches. So I use Trimble Business Center along with the terrain model that we created by doing the topographical survey in the first place. And I can create corridor models. And these are effectively a series of straights and vertical curves that ensures a smooth transition to the base of the trench. Because you couldn't just reflect the OGL surface in the base of the trench because the machines would be digging all over the place. So you've got to effectively take out the lumps and bumps from the ground. Dorset is a particularly challenging site for this because some parts of the site have a 68% gradient on them. That's an extreme example, but it varies anything between 10 to 50% depending on the area of the site. So incredibly challenging terrain. And we needed to optimize basically trenches as much as possible to be able to meet that specification. And TBC allows us the tools to do that. So if we just jump to the next slide, Cam, please. We can see some of the models that we've been creating using TBC. So on the right there, you can see the 4 trenches that we are currently excavating in the southwest of England. You can see the terrain there is undulating and it's up and down, and there's dips and troughs. And we can use the tools in TBC, the corridor tools and the alignment editing tools and profile tools, long sections, to do the design. And we can use powerful cut fill maps to optimize the levels as much as possible to get us into where we need to be in terms of the depth. And then once we've done that optimization, we can put together some high quality PDF deliverables to send to our client for approval or for design review purposes. And the tools that are in here have already highlighted a number of issues before we got there. It was by doing this analysis or the design on a couple of the first sections that we identified a major issue between field transitions. That tool or that realization was then fed back to the design team, who have since redesigned much of the scheme to reflect the new topographical data. That realization came first within TBC. If we could just skip to the next one, please, Cam. So once we've created these designs in Trimble Business Centre, we need to, once they've been approved and the project team are happy with them, and I'm happy that they've met the design specification, we need to push that data to the field. Now, traditionally that's done with a USB stick. So you plug a USB stick into your laptop, you drive down the M5 2 hours south from here, and then you run between machines for the day, and you stick the USB in and you download it, and then you run through all 10 machines or 8 machines that are down there, and then you drive back up and you get a phone call and the design needs to change. For whatever reason, they've encountered a service or something's changed, and then the process starts all over again, drive back down. Obviously a complete waste of time, complete waste of everyone's time. So we use a cloud-based management solution called Trimble Connected Community, or soon to be Works Manager for us. Now this is live on the internet. I can push designs directly from Trimble Business Centre to the cloud. Those designs are then pushed to the field, to every machine we have in the field with a SIM card that's on 4G network. They can be there within 15 minutes. The machines probe the server every 15 minutes to see if anything's changed. The driver, if they want to, can initiate a manual sync. So it's almost instant. It's as fast as the cell network can deliver that data. The design can be there. So if we encounter a service or if there's a design change, I can very quickly react to changes or requests for changes, push that data to the field, and I can know from the comfort and safety of the office that every machine on that site will be updated with the latest data. And the old designs will automatically be purged. It quite literally kicks the operator out of the design they're in. So it's design updated remotely. They go back in and it's changed if it needed to change in that particular section.
Sorry,
that is massive. Sorry, Andy.
That's all right. Just wanted to ask, so that's really, really good stuff. And I just wanted to, we've got some really good questions coming in. So, I mean, obviously, when we get to the end, we can go through some questions, but it's just nice to kind of try and feed some in as we go. So there's a question here from Adam Hems, who says, how do you address the problem of low 4G connectivity on site? Can equipment be connected with a local Wi-Fi if available. I'm just asking you, Sam, if you've experienced any kind of problems with this.
Yeah, this is an interesting one. So I think in the UK, we are quite fortunate in the fact that we're a small country and you're never too far away from a cell mast. Generally, network coverage is not really an issue for us. The reason we went on this particular site, we've deployed a solution called IBSS, Internet Base Station Service, which is sort of a byproduct really of using Trimble Connected Community on all of our machines. So we have a local base station that sits on the cabins on the site compound. And then traditionally on a smaller site, the corrections from that base station will be delivered over radio through all the machines and rovers from the engineers. Because of the size of this particular site and the nature of the topography, radio would only really reach about 1.5 kilometers. So this IBSS solution allows us to deliver these corrections over the internet. So internet connectivity for us is crucial on this particular site, but that's not to say we're solely reliant on it. What's quite interesting, Trimble have generally thought about solutions for everything. It's just using the equipment in a slightly different way to realize those solutions. So it hasn't happened on this particular site because the coverage is pretty good. But if you had a bit of the area that was of poor connectivity, what you could do is you could establish a repeater station, so a little modem that sits somewhere halfway between where the issue is and where the machine is that you want to send corrections to. And that could receive the signal over the cell network and it could broadcast that over radio or broadcast that over Wi-Fi if it needed to the local machine. If it's a smaller site and you don't have a base station, but you've got an engineer with a rover, many people realize this, but the rover can be just sat over a control point on a local Wi-Fi network and send that to the machine. It doesn't have to be all or nothing, and it doesn't have to be either cell network or either radio. It could be a combination of both or all. So yes, there are connectivity issues, but they're generally solvable one way or another.
Great, thanks, Sam.
So yeah, just to finish up on this slide, pretty much as a business now, all of our next generation machine control systems are come ready enabled with a SIM card. So we remotely monitor them and we can remotely manage them from wherever we are in the country, which is a massive game changer for us, really. If we could just jump to the next slide, Cam, please. So on this note, monitoring and operator support, because all the machines are on the internet now, we can remotely log in from anywhere, view a live screen of the operator, and we can see diagnostics on those particular machines. We can dial in and support the operator to work in a new, different way. I often get phone calls saying, how do I do this? Or I want to do this. And I can quickly dial in, and instead of spending half an hour trying to describe a menu over the phone, I can very quickly see the menu and say, okay, click that, click that, click that. And then that's solved very quickly, and they can start using technology in a different or more innovative way. So on the right here, we can see the Trimble Earthworks web interface. So we can get a live status of the machine, the corrections it's receiving, the tolerance it's working to, the current design that's loaded. And on the left, we can see the live operator's view of the screen. So it's a very powerful platform. And in terms of troubleshooting and supporting, there are very few things out there that can rival it, I think.
Okay, Sam, sorry, just before we jump on, I'll just jump in quickly. I'm just curious to know kind of how is it then, what's your experience with the operators themselves? Like, does it take them, I mean, obviously each operator is going to be different and have different, different levels of expertise. I get that, but, on average, how long does it take them to kind of get up to speed with using this, and kind of what have you kind of had any kind of particular feedback from them that, might be a little bit surprising?
So I think Cameron touched on this earlier, that there is definitely, in my opinion, a bit of a generational shift in the perception of this equipment. It's definitely getting better, but I don't think it takes people very long at all, to be honest with you. I find a lot of our operators have come from the older GCS 900 system. So they're already familiar with machine control and the basic principles of it. But having the extra computing power and the large display, they can configure the screen much more in a way that really helps them and enhances their workflow. There are issues. There are people who are resistive to this technology, but I'm pretty open, and I always give my number out and say, call me whenever you need to. I can log in, I can help you, I can support you, we can train you up as best we can. We spend a bit of time initially on site getting everyone up to speed with it, how to change designs, how to select alignments, how to set the screen up so you've got your cross section, your plan, work with your cut fill map so that you know what you've graded is correct. And it's very much, if they want to buy into it, they will. If they don't, it is a bit of a struggle. But it is such an easy platform to get to grips with. It runs on Android. If you can use an Android tablet, you'll be fine in Earthworks instantly. You get to grips with it.
Can I just add a little bit of 2 cents into that, Andy, as well, just some of my experience? What we've also found is a lot of the time is just getting the guys to actually give it a go and get in and use it. And most of the time they start using it for a little bit and then they don't want to let it go. And we've seen that when we've tested out new stuff. I always remember example years ago where we were testing out a receiver that had more constellation support, and all the other dozers, they were sitting and stuck because the GPS wasn't good enough, and this guy had this massive ass smile from ear to ear, looking out, yelling at the other guys because he was going and you couldn't. And this guy was a guy that was sort of the day before a little bit resistant and didn't want to do it, and he could see it. And then also with, say, Trimble Earthworks, there's been a huge amount of effort and user experience and really designing the operator interface for the users. There's help buttons and informational notes and sort of tips and tricks and stuff right available to the users to really help get over that barrier. And where we've come from, where we are now, it's so much easier, so much more user-friendly, I guess, and intuitive, that really helps reduce the barriers.
Absolutely, I'd agree with that. I mean, I always let operators know, top right, you've got a big button. There's a load of really easy to read, well-written help guides in there with diagrams. There's not much in there that you can't find out yourself. It doesn't tend to stop the phone calls, but it helps. But it is incredibly, they've put a lot of time and effort into the UI. I think that shows in this next generation. It's very slick, very slick.
Okay, great. Thanks, guys. And then just quickly before we move on, we've got a question here from Bridget Leary. It's a little bit broad, but it's to you, Sam, and it just kind of asks, what challenges, if any, did you face kind of when using this technology?
Good question. Initially we had some issues around connectivity, getting files to sync and sorting out our network and modems in such a way that we could get it all up and running. But I think we've dealt with quite a few of those issues now. That works really reliably for us now. We do occasionally have issues around parts, and that we're getting better internally at dealing with that. So side tech supporters at the minute, if we have an issue with a sensor or a pod through damage or something along those lines, but we're getting better internally at dealing with that ourselves. It's like anything, it's a system. They're a bit bolted together, and if one bit in that system has an issue, it can affect the operation of the machine, yeah. But I think it's about, if you adopt this technology, you need to put the time and the effort into learning how to fix it when it goes wrong. And I think as a business, we've really come leaps and bounds with that now, to a point where we can very confidently, for the most part, get things up and moving again, where we have direct control over the ecosystem on that particular machine.
Great, thank you, Sam.
Should we just jump to the next slide, please, Sam? So the last bit I need to touch on, really, second to last bit, we've taken the design data, we've created a 3D model in Business Center, we've issued that model to the cloud. It's been downloaded from the cloud by the machines. The operators have started to work to that model. And now we need to try and close the loop back to the office to realize our connected construction center. So we were quite clear at the beginning of this project, we wanted to use machine telematics and live machine data capture, which not many contractors in the UK have trialed or used yet. I think it is fair to say that we've really taken this technology and we're trying to push it and see what we can do with it. In a bit of a learning curve, but I think we've got quite far with it now. And like I said in the start of the presentation, what the lessons we've learned on this site are now trickling down into other sites. And we will be using this technology moving forward in quarries, landfills, and all sorts of other little jobs that we pick up along the way. So machine telematics, for those that are unfamiliar, we can turn the blade or the bucket of that machine into a surveyor. So the machine, as it's grading to that surface, or as it's stripping topsoil or stripping overburden, because the update rate is so high, it's constantly tracking the tip of that attachment, the bucket. And it generates a dense point cloud effectively. We get a 300 mil square, we get a point every 300 mil. And that data is uploaded constantly to a cloud-based platform. And we can visualize the data that comes back from the machines on this platform. And we can actually go one step further. We can start to run volumes between design surfaces and as-built surfaces from the machine. So without sending a surveyor anywhere near the site, we can take that data, we can run volumes, we can check that we're on grade. And this has been immensely powerful for us in many areas, and we use it on a daily basis. So the trenches that are currently being excavated, we get a real-time image of the depth of those trenches, and we can make sure by comparing it to a design surface that we're on grade and we're heading in the right direction. And we've used it extensively on this site to track topsoil strip volumes, subsoil strip volumes, haul road formations, and for the trenching. So if we just jump to the next slide quickly.
Sorry, Sam, just quickly before we do, and Cam, before we do, just there was a question here from Jao Guerrera, sorry for that pronunciation again, but he's talking specifically about machine data capture, so I thought this would be a good time to jump in with this. Yeah. And he's just asking what's the accuracy level in millimeters of the captured data, and how does it compare to the original BIM model for quality and quantity measurement purposes?
Good question. It's very good. Is the answer? It's as good as it's only as good as the weakest link in the chain. So depending on the correction source, BRS has an advertised accuracy of plus 20 millimeters, plus or minus 20 millimeters. And providing the machine calibration is good and the bucket calibration is good, there's no reason why we can't achieve that accuracy at the tip of the bucket. But if you want higher accuracy than that, there are UTS, Universal Total Station type solutions, where instead of using GNNS, we can use a total station and a prism mounted on the excavator or dozer, and you can bring that tolerance even tighter. So, and all this is obviously backed up by a high quality control network. So the data you survey is only as good as the control that the machines are working to, or the calibration that they're working to. It's all relative, really, but it's as good as the effort you put in to it, if you see what I mean.
Okay, thanks, Sam.
No problem. We just jump to the final slide from me then. So we've got this cloud-based platform for viewing the machine telematic data, and we can compare that against design surfaces, and that's exactly what I've done in this image on the left here. This is live data from a machine, and I can compare it to a design, and I can get a live cut fill map for the entire job, showing us that we are achieving the grade within the specification, which is valuable and really useful. but we want to go one step further and completely close that circle back to the office, so we can download point cloud from this platform. And then, like any other point cloud you collect, whether it be with a terrestrial laser scanner or with a UAV, there's an element of cleanup that is required to get that point cloud into the quality that we need it to. So I can go in manually using Trimble Business Center and chop out peaks and troughs and clear just machine crud that's caused by various little issues, only minor. And then I can process that point cloud. I can add break lines and feature lines and add text and annotation. And then to close the loop completely back, I can run high quality as-built deliverables, so PDFs and comparisons between design surfaces and what we've built in the field, which can be delivered back to our client, thus proving that we have met the specification. So we took the specification, we designed, we issued to the machine, we constructed, we monitored using the cloud-based platform, and then we downloaded that data and we compared it back to the design that we had approved in the first place. So we completely closed that circle. And I don't think there are many other technology providers that can offer this complete closed solution. And that was what really appealed to us about the Trimble solution. We can holistically own the machine control process from start to finish, and we don't have to deviate from that seamless workflow. It's uncompromised effectively. So that pretty much concludes my part on how we realize connected construction.
Can I just jump in for one quick comment, Andy and Sam, hope you don't mind. Just wanted to touch on another closing the loop piece, I guess, as Sam mentioned there about how the data and the machines can be sent back up through the cloud. And you can see the site-wide cut fill map and do volumes. With Earthworks as well now, with the recent release, is that the machine operators can hit a button on the actual machine itself, and the system will automatically suck down that whole site-wide model. So you, as an operator, have got an updated cut fill map for the whole site or project automatically. So it consolidates not just what you've done, which you see automatically, but what does it look like as a whole, and what are the other machines done? And sometimes you might find on some sites that it's not, maybe on a weekly basis, you'll stand around in the shed or the container and you'll look at a site-wide cut fill board. That information can be actually in the cab pretty much not very long at all, by downloading automatically from the cloud back to the machine. So to really help close that loop back again, to consolidate what you've done and what do we need to do now, sort of thing. So.
Absolutely. I know. I only became aware that had been released outside of beta last week. So
yeah, no, you should really get on and give us your feedback, because I think you'll like it.
It'll definitely be quite valuable for us. Because we've got a number of machines doing repetitive work in the same area. And yeah, to be able to cross-pollinate between those machines, the data would be very valuable, I think, for us.
Okay, great. I know we're sort of coming towards the end of our time now. We've got a couple of questions that I would like to get to. The more people have sent in. Again, thank you very much for all of your good questions. One of which is from Antonis Simonis from Cyprus, and he asks, is it possible to fit Trimble technology to existing machines? How easy is it? And so broadly and quickly, what does it involve?
That's a very good question, and depending on what the machine is and maybe how old the machine is or the manufacturer, it will depend. But Trimble, I mentioned earlier in the slides about it, what we call Trimble Ready. So we've got specific brackets and stuff designed for specific machines. And in some cases, some machines might already have certain parts that are needed already on the machine that we can connect to. So we in the aftermarket through SciTech, we put things on machines that you already have. So if you want grade control, you don't need to buy a brand new machine. But I guess depending on what the machine is, it might be more suited for certain things. Now, if it's a newer machine that's got electrohydraulics, then we can automate the blade, etc., without having to install valves and other stuff. But we do offer kits, and we can install hydraulics and valves to a machine. But yeah, it really depends on what machine it is. But yes, definitely, there's options out there. It's not too bad. Depending on what it is, it might take longer. But definitely check it out and talk to Sitex or your other dealers, etc. And there's most likely a solution there waiting for you to give it a go.
Okay, thanks, Cam. We've got another question for you, Sam, from Julian, who asks if you have any numbers on how much more efficient the Dorset project was with the software that you used, and if you've got any kind of estimations about kind of time and perhaps money that you guys would have saved.
Is again a difficult one to quantify. I know it is a continual challenge in construction. I'm sometimes a bit envious of manufacturing, really, because it's not always repeatable, because it's not always the same operation repeated identically. It's difficult to compare traditional to the new often. So in terms of hard and fast numbers, it's difficult to put a number on it. But we certainly gain a huge amount of efficiency in the reduced requirement for physical setting out. So, I mean, previously a lot of this work would have been done with, like Cameron was saying, timber pegs, profile boards, batter rails. We can pretty much eliminate a lot of that work bar checking. So a lot of the site engineering requirement now becomes a checking role more than it does a setting out role. And that comes with a number of safety advantages as well, because we're not putting people, whether it be with a profile board or a traveller, they don't need to be at the cutting face of the machine anymore. They can come along after the machine has dug that area and checked it in a safe way, with the machine far away from them. So yeah, I mean, I'm sure there'll be a considerable amount of analysis at the end of this scheme to sort of quantify that. And it'd be really interesting to see, to be honest with you.
Okay, thanks, Sam. And then just quickly as well, one for you, Cam. This is from Ahmed Bazir, who asks, how quickly is the technology changing? I think he's asking that from the point of view of worrying about maybe service and parts becoming obsolete.
That's a good question. Technology does change. It changes fast. But then when you look at the industry that we're in, we have to make sure that the products are fit for purpose. Sorry. So typically, you won't always see something whiz bang available in the automotive or something suddenly appearing on construction, because we've got to validate it. There's the needs in construction with the environmental dust and vibe and all that's different. With regard to service and support, typically you need to support at least 5 years after we stop shipping something, 5 years with the parts and support service. But I guess one thing that people might not know is that Trimble's just released, or was offering, and it's not in Europe yet, but in North America at least, Trimble Platform as a Service. And with that, it provides technology assurance. Now, with that program, is you can pay like a subscription, and then let's say if we release a brand new display or a new GPS receiver, if you wanted to, as a contractor, you wanted to swap it out, we would give you the new one. So you don't have to worry about, hey, I'm stuck on this old system. Or if you, as a contractor, and Sam sort of alluded to it before, if you have one thing that breaks in the system might be down. And if a receiver breaks or you break a display or something, you've got, Trimble would actually, through Sitex, will swap that out and get you back going again. So there's ways out there, and it might not be for you, but definitely the things that are sold in this industry are built for purpose. We have to supply the parts and service and the distribution and support networks to go with it. And there's ways there to stay current and get replacements, either with just the normal warranty, or say it's the Trimble Platform as a Service, where you've got that extra benefit, right, of if we change something, then you can upgrade, or we will swap it out for you.
Okay, thanks, Cam. So I think we need to leave it there. Unfortunately, we kind of said it would be 45 minutes, maybe a bit more, and we're kind of turning into an hour now. Thank you very much for all of your questions. I know that there's one or two I've not been able to get to, so apologies for that. But the majority of them we have answered. So Sam, thank you very much for your time and for your. It was really useful to get that kind of first-hand knowledge from the site. We really appreciate that.
Yeah, no problem. Thank you for having us. It's been really invaluable for us to be able to present this.
I guess from Trimble as well. Thanks very much, Sam. It's been awesome to
No
for our customers and new customers to actually hear directly from people in the dirt using it and feeling it. So thank you very much.
I think that's a really good thing about Trimble. They're really actively involved with the customer, and it's a two-way conversation. And a lot of what we've suggested has been implemented moving forward into the new platforms and the new releases. I think it's a really good relationship that we're looking to maintain.
Okay, great. So thank you as well, Cam, for your time and for your answers. Very useful.
No worries. Glad to help. Glad to help share the story and get people interested in picking up the phone and ringing SciTech to see what this is all about.
Okay, so that's perfect. So thank you very much to everybody for watching and for your questions. As I said at the start, please do keep an eye on www.khl.com as we will put the full video of this up. So yes, just thanks very much, and yeah, take care everybody. Bye.